to the cloud. Yes. Yeah, I think maybe some of the discussion are worth recording. Yeah, go ahead, Amanda.
Hi, I'm over at SchedMD, and we're trying to get Splurp scheduling level into Kubernetes. And the types of stuff we're looking at is the old scheduler was written to let schedulers play well together, but the framework is very slow. So when we went and looked at a variety of schedulers, very few people are using that full framework, and not in the practical world. And when you're talking about the types of workloads, because it's HPC, AI, and training is what we cover. So you need to know a lot about the resources on those nodes. So going through the classic API where there's a lot of parsing is very expensive. And the way we work is we basically stick it all at a bit string and chomp it through our algorithms and then come out with an answer, including scheduling in the future. So for instance, if you're using half of the nodes in a cluster, you can't just wait for those nodes that are approximate to each other to come up at the same time. You actually have to plan for it. So we actually have workload planning. So that's kind of the types of stuff we're looking at. The current scheduler is like, we'll work with it, but we're going to have to bypass a lot of the current functionality to get it to work well.
Yeah, I agree. Sorry, I didn't get all of it because you had a lot of background noise for me, at least. But yes, I generally agree. I think that's a great point, because I was also thinking that maybe we should start rethinking about presenting resources on nodes. If we are thinking about the next generation of the scheduler, maybe we should also think about how we are presenting resources on the nodes and how we can more effectively or efficiently process those. Right now, Kubescheduler just cares mostly about CPU and memory. There are other resources, scalars, etc., that we are also considering, but they are not like first-class resources, I would call them. And DRA, etc., we are also thinking about adding more functionality to scheduler for processing those. But again, everything else is kind of like in addition. It's not like processed in a first-class way. So yes, I think maybe we should rethink about how to present many other resources and how to bring any sort of like, I don't know, maybe arbitrary resources to the mix and scheduler, define an API to create these resources, and a scheduler processes all of them. So yes, that's also a great point. And I guess Cordelia also has a question in chat. She's asking, what are the, by the way, sorry, Marlo, did I understand your point correctly, or did I miss?
Yeah, no, you understand. We're also looking at DRA stuff because while we also incorporate CPU and memory, the location of CPU more than memory matters. The networking and all the backend and the co-location.
I see. Is it the location of CPU, or is it the location for, or maybe, yeah, I guess maybe it's for like cost optimization, for example, if the location matters, or what for latency optimization, or multiple reasons like that.
So if you're looking for, HPC and training and inference, multi-node inference, which is the stuff that we look at, you care about what's closest to what NIC. So you have to have the CPUs in the right location for that to your workload. So if you're crossing that UPI bus, that does slow you down, for instance. And there's other people highly optimize these things. So I don't know the full range of optimizations, but where your workloads are matter, and where they're located in comparison to other parts of the workload matter.
Yeah, I think that's part of the requirement of logical scheduling. So basically, the current paradigm is that we place the path to a node. But in a real world, the node is not the minimum unit that is the workload wants to place into. Maybe it's UMA, it's some specific rack or some things. So maybe we have to change the paradigm and the interpretation, like in kubescheduler, to make the minimal unit to place the workloads programmatical and configurable in what way? In a descriptive way, so that can achieve better effects to fit more use case, I would say. Like right now, a lot of not only CPU memory, but some IP can be a resource, some other context that the scheduling needs to be aware of will impact the runtime part placement instead of just the CPU memory. Yeah.
I see. Yeah. That's a great point. Yeah, I guess I don't know if John Belamaric is here, but he was also, had a conversation with him, and he was also saying the same thing, that maybe we should also rethink about where to place the pods. It's not necessarily always just nodes. Maybe we should start
Exactly.
thinking about another sort of container in a way to place a pod.
Yeah, for some time it's more lower than node, but sometimes can be higher level. It just plays into a rack, or it's a physical node or zone or something. Yeah.
Yeah. And also, Cordelia, you have a question about the backward compatibility guarantees. Definitely, the answer is yes. We have API, we have like KPI behavior, etc., that we will have to keep backward compatibility. At the same time, luckily from the get-go, Kate's always had the option of choosing your own scheduler when you create your workloads. So you can add a new scheduler to the system and keep the existing scheduler. The existing scheduler can be the default scheduler, and for some of your workloads, you can use a different scheduler. So the benefit of this is that you can bring a new scheduler and gradually replace existing scheduler. It doesn't have to, get the new scheduler to exact same level of complete backward compatibility before you can add it to the system.
Okay, that makes sense. This is sort of a newbie question. I was sort of just wondering, like, is there a guarantee that's like an API contract around?
Yeah,
it will
it
always
is.
schedule these jobs in the same way as like it did before.
So I will give you some example. This what is scheduling side API. For example, priority class. The pod has a priority. It will impact a lot of things like preemption, like the ordering inside the kube scheduler's queue, and also the affinity, like node affinity, pod just spread constraints. Those are all can be either hard or soft constraints APIs. That is Kubernetes scheduler will be responsible. That is guaranteed. As time goes, it should be always be a contract with the user if they specify the corresponding API in their workloads. And also there are some, this is user and workload API. There are some other configuration APIs, I would say, that is to define your scheduling policy, like more impact, more etc. Also, some of those configuration can control the behavior of preemption, for example. Yeah, those are the APIs right now we have.
Okay, so there's policies and constraints that do have an API, and those would have to be respected because of the backward compatibility API contract.
Yes, exactly.
Okay.
That means if we come with a V2, then definitely those APIs should be honored.
Got it. Thanks for the examples.
All right, cool. This was a useful conversation for me. Thank you. I don't have any other questions. I don't know if any other folks have any questions or comments. Otherwise, maybe we can cut this meeting short. All right.
All right. Yeah, I'll give you some time back. And yeah, thanks for joining. See you in 2 weeks. Yeah,
Thank you.